Okay, so today we're going to start with just working a few problems from section 4.5. Just as a review, I know that one was our exponential growth and decay one, so I promised you guys would do that. So I'm going on. It's hard for me to share, but the way I have it set up. But the very first one, like some of your questions, the very first one on number 1, it just says that you're supposed to find if you have A equals P plus PRT, and then you're solving it for T. So keep in mind that one is an older problem, so that was kind of a review. Oh, you can't hardly see that, can you, Kirsten? Do you remember what we did? What would we do, sir, if we're going to try and get T by itself? We would need to move over what first? The P that's by itself. So in other words, I'm going to subtract it from both sides, and I'm just going to leave it as A minus P is equal to PRT. And then the next step would be number 1, 4.5. Since this is being multiplied, P and R is multiplying by T, then we need to go ahead and divide by PR. And that would be your answer then. T then is equal to A minus P all over PR. So those are kind of some of the problems that's what they start with on 4.5. I want to go ahead and do a couple more that are just like some of the exponential problems we did yesterday. Let me see if I can get it so I can see my screen and this, and I can't. Why are you not working with me today? I do not know. So let's go. I'm going to go ahead and keep going. So if I keep going down, like if I had question, I'm going to have you jump to question number 9 if you had that one. So in the book, my problem says an artifact originally had 16 grams of carbon 14 present. And so in this case, my A sub odd is going to be then 16. And then it says the decay model for this particular element, or I guess it's artifact, would be equal to A equals then 16E, and then the rate is going to be negative 0.000121, and then times T. And so in this question then, what they're asking, it says how much. Describe the amount of carbon 14 present after T years, and use the model to determine how many carbon will be present when T equals then 9987. So I'm assuming you don't have exactly the same numbers. I mean, that's kind of the way they do this. But in this case, our initial amount is 16, and that's what's going. That's where we start. So that's where we're going to have A. They want to know how many grams are available. So they're looking for the grams after so many years. And so really all we have to do is substitute my time into my time equation and then solve. Okay, and so I'm going to let you finish that one. Let's go ahead and go down to maybe another one, like 10. I wanted to give you one where it's kind of where you have to find the half-life. Okay, so in this one, on number 10, they're giving you the rate also. Let me see if I can jump down. 11 is a half-life. Complete the table to the right for the half-life of a certain object. So the half-life. Okay, that's it. Okay, so number 11. Why don't you go ahead and give me your numbers? That way I can. What does your half-life say? 14.8. All right. So in this way, that means the T is going to equal 14.8. And in some ways, it looks to me, and it was like a chart that they gave it to you, so you guys will kind of look at that. So, and I guess it was the opposite. The half-life is on, this part is up here, but it says half-life. So half-life means, again, no matter what we start with, we're going to initially divide by, divide the initial amount and get half. So in other words, if I have A sub odd is going to equal then e to the k times t power. And I know that my half-life means that whatever I start with here, this has to be 1/2 of it. And so I actually have enough information by just knowing that my t is going to be 14.8. But what I want to do is start off, think about if you have to divide both sides by a sub aught, what happens to a sub aught? They cancel. And so you're left with then 1/2 is equal to e to the kt power. And then, as we did on 4.5, what did we do to solve, since the k and the t is in the exponent? Yeah, you're going to take the natural log, and where's my calculators? Okay, so the time, sorry, I could have stayed one step and written it down. Time is going to be 14.8 when it's the half-life. So that means this t has to be replaced with 14.8. So I still have then 1/2 is equal to e, and I'm going to go 14.8 times k, and I need to find out what my rate is. So to do that, did you tell me the ln of both sides? So I'm going to take the ln of 1/2 is equal to the ln of this e to the 14.8 times k. And now what?
Like the ln of e would just kind of go away.
Okay.
And then you would move the 14.8k
to the front. Good.
Yeah.
You're right, it kind of goes away because I'm going to actually just take the ln of 0.5, and that, when it does go away, I'm going to replace it with the decimal equivalent. So it's going to be a negative 0.6931. I'll just leave it right there. You are correct. This power, because of our power rule, goes out in front, and then we know the ln of e is just going to be 1. And we're going to go over a few of those review problems in a second too. So I have then equals 14.8 times k. And then the next step is that I would just need to divide both sides by 14.8. Goodness. So then my answer should be for t, my rate would be then negative 0.0468. Do you have to put anything more after that?
Mine says around 6 decimals.
6 decimal place, so we got to go a few more. So 1, 2, 3, 4, 8. How about 3? Mine's 3, 4.
Yeah.
Yep, you got it.
Just needs a lot of decimals.
Lots of decimals, and we kind of talked about that as any way you can try and keep a lot of decimals, and it does make a huge difference, especially in. Was there anything else more to that problem?
No.
So sometimes we have to actually find the next one, like what would be if it was, Go down to the number 13, and we'll do that one, and then we'll kind of finish. Mine says, okay, we're going to still use the model A equals A sub aught e to the kt power. And it says the half-life of a certain substance is 29 years. What does yours say?
23.
Okay, so I'm going to go T equals 23. And then I'm going to say that it says find how long will it take for the sample substance to decay to 63% of the original. What is yours?
76.
Okay, so we're going to do a new problem, and it's going to be question mark how long until you have 76% of A. Is that what the next one? So there's 2 parts to this one. So in this case, even though what we wanted, the first one, it says it'll take approximately, let's see, okay, I think it's the end. So what we have to do is first find, we don't know the K, we just know that the half-life is 23 years. So what that means is that, again, I'm going to replace my amount that I'm looking for. It's going to change to 1/2 of A sub aught is equal to A sub aught E, and then I'm going to have T is going to be replaced with my time, so it's 23 K, 5. There's a 23. And just like we did before, a sub aught cancels out, so we don't have to worry about that. And then we are going to take the ln of both sides. So I have the ln of 1/2 is equal to e to the 23k. So grabbing my calculator, I'm going to use the ln of half again. So the ln of 0.5 is the same. So I'm going to just write a few things down so I know I can find it. 0.0693, and then it continues, is equal to. Now when I take, again, I think let me just go ahead and go the ln of e to the 23k. That means that the ln of 23k is going to go in the front, and then I'll have the ln of e, which is just going to be 1. So I end up with 23k. So then I'm going to divide my ln of 0.5, which was the 6.69, divide it by 23, and I get my value of k is going to equal negative 0.030137. Okay, and I'm going to keep it in my calculator because now what the next part is, I've got to know what is going to be 76% of A, and before, this is going to be the K that's going to be for everything, but remember originally when we set it up, we had a half-life of 23, so it means our time is going to change, and so is our amount. But in this case, it would be the same as 0.76, because I'm changing that to a decimal, times A sub aught is equal to A sub aught, e to the k, which now I'm just going to write a few of the decimals, 0.003000137. So it's a lot like the same this problem we had before when we solved for k, but now we're going to solve for time when we want to know 76% of the amount of solutions left. And just like it did before, a sub aught cancels. Okay, so I'm left now with taking the ln of both sides. So I have the ln of 0.76 is equal to the ln of e to this whole mess. So negative 0.0300137t. And I'm going to go ahead and go to my calculator. I'm going to go the ln of 0.76 is equal to a negative 0.2744. And remember, just like it did before, this is going to come out in front because it's a power, and then I'm going to have the ln of e, and the ln of e is just 0.0300137t, and then to solve, that means I need to divide both of those together. So I'm going to say I've got the 0.227 in my calculator. I'm just going to go ahead and go divided by, and I'm going to arrow up until I find out where I had my negative 0.030, goodness, and then I'm going to hit answer. So then I have my time is going to equal then 9.1. Did you have to, what do you round to on this one? Round.
Round all 4 decimal places.
Okay, so let's go 106, and then this would be then 4. All right. Kind of.
9.10627.
Okay, 9.1064.
Years?
And then let me go back to it says in this one, go back to your teach because it was 29 years.
Mine says
Oh, final answer. Round the final answer to 1 decimal place as needed, and round all the
there we go.
all the other ones to 4. So change yours to 9.1, and you should be okay.
Okay, yeah, there we go.
I know. On this problem, you do have to. Rounding gets me probably more than anything else on any of the homework problems that I've had. So far that makes kind of sense. Yeah. All right. Let me talk a little bit about 2 things that you have, because today is Thursday. I don't know that I'm going to get with Kristen tomorrow. And Ingalls, hey, I would love to work any problems that you would like me to see worked, but I'm not probably going to work problems because I don't know if we're going to have any time. Yeah. So I wanted to kind of go over 2 things that are in your chapter test under the lesson plans. The first one is just a practice review test for Chapter 4 review. And again, I would be happy to work any of those problems. I also have included the key in that on your lesson plans so that you could work the problems and then go ahead and go back and check your work. That's ideally what I'd like to see, but I get it. If you notice the first couple ones, 1, A, B, and C, and D, are a little different because I pulled them at the front for the key. Because what I'd like to do, they're the same problems that I have on number 6, and so that kind of makes my numbers kind of jive. But guys, I'd like to have these without a calculator. So when you get your test, I'm just going to give you one page of this that you're going to turn in first. It's going to have just 4 simple problems. It's going to have for logarithms, and then you can use your calculator after that. So, Kristen, are you ready to put your calculator away? Let's quickly go through these so we have them online. This without a calculator. If I have log base 5 of 125, number 6. So remember, this is 5 to what power is going to equal 1 over 125, 125th?
Would be negative 5.
Close. You're right. 5 times 5, yes, is right. But negative what? 2. You have got it right. Negative 2. The next one, remember, this is actually log. It doesn't have it, but it's going to be log base 10 of 10 to the 11th. What do we know that that's equal to? Okay, now remember, you're right. Log base 10 of 10 is going to be 1. But that 11th, it comes out in front, so it's 11 times 1, which would be then just 11. Good. Okay, so anytime it's a power. Now, on this one, kind of the same idea. So it's the ln. So remember, ln is the same as the log base e of e to the 2x. So just like on our problems before, we move that 2x out in front, right? So then we have 2x times log base e of e, which we know is just going to be 1. And that's the same. So anytime you see the ln of e, it's 1. And so my answer on this one is just 2x. And then I have the log base 3 of the square root of 3. So remember, this means 3 to what power, I'll just put a box, is equal to 3. And if I write the radical as a fraction, it's what? Like the square root of 3 is the same as 3 to the 1 over 2 power. So remember, this is assumed it's 2 here, so that means it's on the bottom. So the log base 3 of the square root of 3 is just going to be then 1/2. Keep in mind, if I also go, let me just change it to log, I'm going to change the whole problem, give you a new problem. Log base 5 of 5, the third root of 5. So in this case, this is 5 to what power would equal 5, and then the cube root, the third root of 5 would be 5 to the 1 over 3. Good. And so in this case, this is actually just 1/3 as well. And we can, again, just you're going to have a few of those that we just have to practice. Just have to know your common logs, and it'll be just 4 problems, so it's not a huge part of your test, but gosh, I don't think I could get by. I need to have you understand that logs are going to be those exponents. Okay? All right, so that kind of explains that. And there's some extra problems on each of the like I said, that you will have the logarithm problems. The population. This one is very similar, where we just found k. I think that when I substitute this in, you have the projected 2000, so this is going to A equals A sub ot e to the kt power. In this case, the second one, the 60, it's a growth, so it's 69.3 is going to equal the 49.4. That's the original. And then think about from time, if I go from 2007 to 2047, that means t has to be 40. And then you'll find then the k here. Then you have an exponential one we just found, like the half-life, which we just did, and then we also have one just like what we did in the homework problems. Both of those do have like sample problems on that if you want to look at the key. I've written out how to solve those, but anyway, hopefully the test will be fairly good, and if you want me to work any other problems, I'd be happy to. So, all right.